This is for Year 11 methods. It's background information about the square root function, which comes out of 4.2 in Chapter 2. This is in the form of y equals a x to the power of n, or in this particular case n equals 1/2. So it's y equals the square root of x. What does the general pattern look like? When x is a negative number, y is undefined, it does not exist. When x equals 0, the square root of 0 is equal to 0. When x equals 1, the square root of 1 is equal to 1. We need to jump to 4. When x equals 4, the square root of 4 is 2. When x is 9, the square root of 9 is 3. Square root of 16 is 4. So if I was going to look at the graph, 2, 4, 6, 8, 10, 12, 14, 16, where that's x, at 0, it's 0. At 1, it's 1. At 4, it's 2. At 9, it's 3. We end up with what would be a parabola that's on its side. So I've actually got a parabola that would normally sit, if I exaggerate the y values, that there. So what would the general forms look like? Y equals the square root of x plus 1. This plus 1 moves the graph of y equals the square root of x 1 unit to the left. Therefore the graph will cut here at -1 and look like that, where if x equals 0, the square root of 1 is 1, so my y-intercept is going to be 1. If I have y equals the square root of x minus 1, that's actually going to move it 1 unit to the right. So here at 1, and that's like that. Because I need a second point and there is no y-intercept, if I make up a value of 2, if I make x equal to 2, 2 minus 1 is 1, the square root of 1 is 1, so that's at 2 and 1. So there's my 2 points. If I have y equals the square root of -x, this negative reflects it over the y-axis, so in actual fact the graph's going to look like this instead, where when x equals -4, the square root of -4 is the same as the square root of 4, which is 2. Okay, 4 more examples that involve transformations. This negative out here is a reflection over the x-axis. So instead of it being here, the graph's going to reflect down there and look like that. In this one here, I have two things happening, and I'm going to have a negative. Take that out, I've got x minus 3. So this tells me it's reflected over the y-axis, and this tells me it's moved 3 units to the right. So it's moved over here to 3, but the negative on the x means that it's reflected this way. Here I have a reflection over the y-axis and a reflection over the x-axis. So the graph is going to normally be like this, but the reflection over the y-axis makes it look like that, and the reflection over the x-axis makes the final product look like that. And the last example, 2x minus 1, I've got a dilation, so I'll bring the 2 out, and I've got x minus 1/2. It's actually been moved to the right 1/2, and the 2 gives it a dilation so that it's steeper. Okay.